Imagine sitting down in that completely silent exam hall. You're staring at a complex Cambridge mathematics past paper. The clock is ticking. The tension is absolutely palpable, and your mind starts racing. Welcome to the explainer we call the surgical theater. I am your host, and today we're looking at mathematics not as some boring, abstract list of concepts to memorize, but as a kit of precision surgical instruments. Whether you are tackling syllabus 0580, pushing through 0606, or battling 4024, 4037, or even 4040, the strategy remains exactly the same. You need precision. Consider two typical test takers we see all the time. First, there's Alex. Alex is the kind of student who overloads every single answer with raw math facts. He just dumps everything he knows onto the page, but he completely lacks analytical focus. Then there's Sam. Sam rushes. She sees a number, panics, and entirely misses the specific command words of the question. She's moving fast, but in all the wrong directions. Today, we're going to fix those common mistakes. We're going to equip you with the exact definitions, the precise frameworks, and the steady hands needed to dissect these problems with absolute surgical accuracy.
To make sure you don't fall into the same traps as Alex and Sam, we have logically grouped this ultimate mathematical survival kit into 4 clear, distinct themes. First up, we're tackling the language of precision. Second, we'll look at geometry and spatial tools. Third, we'll master decoding data and statistics. And finally, we will wrap up with algebra and number mechanics. Let's get straight into the operating room.
Section 1 is all about the language of precision. We're starting with sets and symbols, which are essentially the fundamental grammar, the scalpel, if you will, of our entire toolkit.
Let's start with the universal set. Think of this as the literal operating table of our toolkit. It is the set containing all possible elements for any particular problem. Listen, if an element is not in the universal set, it simply doesn't exist for the purpose of that question. Period. This is exactly where Alex always loses marks. He ignores the boundaries. In a recent 0580 past paper, the universal set was defined purely as integers from 1 to 10. But Alex, trying to show off to the examiner, included 11 and 12 in his working because they fit a neat little pattern he spotted. The result? Total disaster. He completely failed to apply the absolute boundary of the universal set, ignored the primary assessment objectives, and lost the mark instantly. You have to respect the boundaries of the problem.
We also need to clearly contrast intersection with union to prevent an incredibly common trap. And it's one that Sam falls into constantly when she's rushing against the clock. Intersection means elements that belong to both sets. If you picture a classic Venn diagram, intersection is just that specific overlapping middle section. But the union is much broader. It means all elements that belong to either set or both sets combined. Sam sees that U-like symbol for union, she rushes and she only writes down the overlapping numbers, missing the actual command of the question entirely. Remember, intersection is the strict overlap, while union is the whole shebang combined. Now, before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, Geometry and Spatial Tools. When you're dealing with shapes, vague descriptions will literally earn you 0 marks. You need specific spatial instruments.
Let's look at a rhombus. A rhombus isn't just some slanted square. It requires exact defining properties to distinguish it from other quadrilaterals. It has 2 pairs of parallel sides, 4 equal sides, equal opposite angles, and crucially, this is the big one, diagonals that cross at perfectly right angles. Originally, Sam would just scribble down, all sides are equal, and immediately lose points. This is where top students apply a variation of the Peel framework: point, evidence, explanation, link, even in math. Your point is identifying the shape as a rhombus. Your evidence is stating that all 4 sides are equal. The explanation is pointing out that the diagonals cross at right angles, and the link is mathematically proving why the internal triangles are right-angled based on those diagonals. The voiceover in your head during an exam needs to recite these exact properties for maximum precision.
Let's clarify a crucial distinction that trips up literally thousands of students every single year. Congruent shapes and similar shapes are absolutely not interchangeable terms. Congruent shapes are exactly the same shape and size. They are perfectly, flawlessly identical. If you slide one over the other, they match up edge to edge. Similar shapes, however, are just an enlargement or reduction of one another. The corresponding angles are equal and the corresponding sides are strictly in proportion, but the overall size is totally different. Alex once used the word similar in a proof when he actually meant congruent. That single wrong word completely destroyed the logical link of his entire proof. Words have distinct mathematical weight. Do not mix these up.
Consider this your vital area cheat sheet.
From the simplicity of a rectangle's length times breadth, to the triangle's half base times height, all the way to a trapezium's slightly more complex formula using half the height times the sum of the parallel sides, and of course, pi r squared for a circle. Memorizing these specific formulas is non-negotiable. It's the bare minimum. When you face a really complex compound shape on page 4 of your exam, your goal isn't to magically guess the total area. Your strategy is to dissect it. Break that massive shape down into these core building blocks, step by step, using these exact formulas.
And then we have Pythagoras' theorem. A squared plus b squared equals c squared. This is an absolute, unbreakable law of spatial mathematics when you are dealing with right-angled triangles. It states the exact relationship between the lengths of the three sides, where c is always the hypotenuse, the longest side directly opposite the right angle. Whenever you see a right-angled triangle, or maybe you've just proven one exists because you applied your rhombus properties and saw the diagonals cross at 90 degrees, this theorem is your primary diagnostic tool. It's your go-to move.
So here is the big question. How do we extract meaning and measure the spread of really complex information? Because in the real world and in the hardest parts of your Cambridge papers, you aren't just given neat little triangles. You are handed massive, messy sets of numbers. Stop scrolling. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's bring out our diagnostic tools.
Section 3 is decoding data and statistics. It's time to look at the specific terminology we use as diagnostic tools to extract the hidden truth within huge data sets.
I want you to imagine we're doing a rapid data scan right now. You've got 60 seconds on the clock. First step, you must contrast discrete data with continuous data. Discrete data takes on certain, distinct values, usually whole numbers. Think of it like counting the number of peas in a pod. You can't possibly have half a pea. It's counted. Continuous data, on the other hand, can take on literally any value within a certain range. It's measured. Someone's height, or the time it takes to run a race, is continuous because it can be measured to infinite decimal places depending on how accurate your stopwatch or scale is. Applying a continuous data technique to a discrete data set is a guaranteed way to derail your calculations and lose assessment objective points.
Okay, challenge 2. Find the flaw. Let's look at range. It is defined as the difference between the largest and smallest data values. This makes it our quickest diagnostic tool to instantly measure the spread of a dataset. But here's the flaw Alex always makes. He looks at a dataset, spots the number 45 as the highest number, and writes down range equals 45. Do you see the flaw? Range is an operation. It is a specific calculation, a subtraction, not just a descriptive label for the maximum value. You have to actually calculate the difference between the highest and lowest numbers to demonstrate to the examiner that you understand statistical spread.
Challenge 3 is speed processing. Let's break down the 3 different ways to measure an average. Each one gives us a very unique, highly specific view of the data's typical value. The mean is found by adding together all the data values and dividing by the total number of values. The median is the strict middle value, but only after the dataset is completely organized in order of size. And the mode is simply the value occurring most often. Sam was doing a speed run on a statistics paper recently, and she calculated the mean when the command word specifically asked for the median. She did perfect math, but answered the wrong question, throwing away easy marks. Always double-check which average the problem actually requires.
Finally, we reach Section 4, Algebra and Number Mechanics. If geometry is all about spatial awareness, algebra is about absolute, unbending logical laws. First, we have to distinguish rational numbers from irrational numbers. A rational number is any number, positive or negative, that can be cleanly written as a fraction. This includes all integers and all terminating or perfectly recurring decimals. An irrational number, however, is a rebel. It is any number that absolutely cannot be written as a simple fraction. Any decimal which neither terminates nor recurs is irrational. Think of pi, or the square root of 10. If you type it into your calculator and it just spits out random digits forever, it's irrational. Building your equations correctly requires knowing exactly which type of number you are operating on.
Let's review another absolute mechanical rule: prime numbers. A prime number is a number with exactly 2 factors, the number 1 and itself. The sequence goes 2, 3, 5, 7, 11, and so on. But there is a massive trick here, a caveat that catches out thousands of Cambridge students every single year. The number 1 is not a prime number. Why? because the mathematical definition demands exactly two distinct factors, and the number 1 only has a single factor, itself. When a probability question asks you for the chance of picking a prime number from a hat containing numbers 1 to 10, if you include the number 1, your entire probability fraction is wrong. Next up, let's compare direct proportion with inverse proportion. Two quantities are in direct proportion when an increase in one causes a proportional increase in the other at a constant ratio. It's simple. Think of buying apples. More apples means more cost. They move together. Inverse proportion is the exact opposite. It's where one quantity increases while the second decreases, meaning their product remains constant. Think of speed and time. The faster you travel, the less time it takes to arrive at your destination. Applying these clear definitions when you are setting up your initial equations ensures you will never get the mathematical ratios backward.
Financial mathematics is another heavily tested area on these papers, and you must perfectly differentiate simple interest from compound interest. Simple interest is calculated only on the initial principal amount you deposited. It is just a flat rate added consistently over time. It's linear. Compound interest, however, is paid not only on the principal amount, but also on the accumulated interest from previous years. It builds on itself. It grows exponentially. The formulas are different, the mechanical behavior over time is different, and applying a simple interest calculation to a compound interest question instantly invalidates your entire multi-step answer.
And for our final set of tools, let's look at the laws of indices. These are the gears of algebra. When you multiply numbers with the exact same base, you add the powers. When you divide, you subtract the powers. A power raised directly to another power means you multiply those indices together. And crucially, never forget this. Any base raised to the power of 0 always equals 1. Consolidating these essential algebraic rules gives you a completely unified view of number mechanics. Knowing these laws by heart is your ultimate tool for simplifying terrifyingly complex algebraic expressions without a second of hesitation.
So, we've laid out the entire toolkit. Are you equipped to perform mathematical surgery on your next exam? You now have the full system. Remember the 3 rules that guarantee top marks. Rule 1. Command word decoding. Don't rush like Sam. Read what the question actually wants. Rule 2. The PO framework application. Make your point, back it up with mathematical evidence, explain your working, and link it to the answer. Rule 3. The time management matrix. Know your tools so well that you don't waste time second-guessing formulas. The next time you sit down with a complex math problem, don't just stare at the numbers and panic. And please, don't overload the page with useless facts like Alex. Take a breath, look at your toolkit, and select the precise instrument required. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.